Here we want to find the equivalent capacitance, so I start out in parallel. I add 2 and 1, 2 and 1, which is 4 and 2. 4 and 2, 4 plus 2 is 6. And then in series, 6 plus 12 is 4. Okay? So the answer is 4. How did you get 6 plus 12 is 4, Mr. Farrell? Product over sum. 6 times 12 divided by 18 is 4. Questions? Okay, so now we know the equivalent capacitance, so I'm going to find the charge on the whole thing. How do I find the charge on the whole thing? I know the voltage. I know that capacitance is charge over voltage, and so charge is equal to CV, and so the answer is 96. So I know there's 96 microcoulombs across here, so there has to be 96 microcoulombs across here. And there also has to be 96 microcoulombs across
he's not gonna release it.
Here plus here. So both of these have to be less than 96. So where do you get, so how do you find between C1 and C2? Well, you take a look at this and you say, okay, which one, they have the same voltage. Why do they have the same voltage? Why does C1 and have C2 have the same voltage? Because they're connected in parallel. If they have the same voltage, then the one that has a greater capacitance has the greater charge. Okay. So the answer is C1, C2, and C3. Questions on that? Okay. What is the charge on C1 and C2 respectively? Well, we just did that. We know that there's 96. We know that C2 is twice that of C3. We know we can set up an equation. 2Q1 is plus Q2 is equal to 96, and we find that 64 microcoulombs is on C2, Q2, and Q1 is 32. Questions on that? Okay. What is the voltage across the capacitor of C3? Well, if you go back to this, if you go back here.
Wait, look here, I actually got these right.
We know that there's 24 volts. We know that this plus this is 24. We know that there's what? There's 16 here. How do we know there's 16 here? Because we know the charge and we know the capacitance. If you know the charge and the capacitance, you know the voltage. It's just Q over C. So 96 over so the voltage then is going to be 96 over this capacitance, which is 12. 96 over 12 is
better. The angle's
16.
better when I hold it up.
So I know that there's 16 here, right? So if there's 16 here, there has to be 8 and 8. Questions? I think most of you were able to do that. That's not where the mistakes were like compounded. Where the mistakes were compounded was coming up very quickly, and that's problem 7. But let's look at problem 6, because we want to find the energy. Now, how do you find the energy? You go 1/2 QV. We know Q and we know V, and we just add them up, and you see U1 is the lowest, and then U3, and then U2. By just multiplying Q times V, and you can then figure out what those energies are.
Can we go over question 5?
How much energy is stored in the capacitor Q3? Well, that's just going to be, you can either do 1/2 QV, you could do 1/2 QV, or you could do Q squared over C, or you could do 1/2 CV squared. So all of these three will give you the correct answer, which is 384. Okay, so all three of these are the same because we're just taking we're taking 1/2 Q times V and we're replacing it in with this formula.
Cause I swear I had the right Q and V. So
Alright, any other questions? You guys good about that? Yes, Will.
Can you just open the test just for this
No.
period so I can see?
Oh, maybe.
Please.
Okay, I'll open it. Alright, I'll open it for this period, but then I'm gonna close it.
What? Oh yeah, okay.
I would like to use this in the future.
You send me that too.
Yeah, I'll send it. Should I just send it in ELA? And then also this chat, obviously.
I'll send it.
She'll send it in ELA.
I think I'm gonna have to make a YouTube video. Cause no one, like a half-hour video is gonna send over text.
Yeah. You're actually the best. It's like you're taking them for the whole class.
No, it's worth it. It's worth it. Especially since I have this storage.
Okay,
So I might as well.
I do not have it.
Number 4,
8 volts.
8 volts. Do you understand why it's 8 volts?
Yes, I just want to make sure that it's just better.
Yeah,
Did he
they're
open
not
it?
gonna be the same answers on the next retake. I'm gonna change the numbers.
Oh, he opened it.
Rank, okay, so now this is where we have issues. This is where we need to put on our thinking caps. Alright. After the dielectric, after we place the dielectric, now there are some like, alright, I know I'm not gonna, well, I could be a little frustrated because the answers here just show some type of ignorance, and the ignorance is that capacitors do not depend on voltage and they do not depend on charge. Capacitance, parallel plate capacitors depend on what? K, U, A over D. So what I'm doing is I'm putting in a dielectric K. Because I put in a K, what happens to C? It goes up. So in this problem, you put in, it just automatically goes up. So some people said, well, the capacitance stays the same. Why would it stay the same? You're putting a dielectric in there. Capacitance goes up. Why? Because you're putting a K value in there. Capacitance goes up. So if capacitance goes up, then something, and, alright, so capacitance goes up. Now, why does the capacitance go up? Because you're minimizing the field. You're decreasing the field. Decreasing the voltage. So voltage goes down.
Oops.
So those are the two things that I'm like, those are slam dunks. You needed to know that. A lot of you didn't. So I did give 2 out of 4 just for writing something down. Okay, I didn't have to. I could have, you know. But for the retake, I'm not going to do that. You're going to have the correct answer.
We're screwed.
So capacitance goes up. Why? Because voltage goes up. That's why. Those are the two things that you had to put in there. Connor.
So when the voltage is, when there's the battery stuck in it, the voltage stays the same, and then you treat.
It doesn't stay the same.
You can,
It doesn't stay the same. It stays the same across this branch.
yeah, not in,
24 volts stays the same. The voltage across this doesn't stay the
because the
same.
equivalent capacitance goes up, right?
Yeah.
And so
You're forcing the voltage to go down. So you're forcing the voltage across this branch to go up.
but like the circuit itself, and then you use that to calculate the voltage on C.
Yeah. But C goes up by this equation. And then why? Because V goes down. You're forcing the voltage down. So because you're forcing the voltage down and the field down, what are you doing to the energy? What's energy equal to? Energy density is directly proportional to E squared, the field. If the field goes down, the energy goes down. Okay, so what happens to the charge? Well, let's look at this equation. Okay, so if we are forcing more charge to this side, then there has to be less charge here. It just makes sense. Conservation of charge. We're putting more charge and voltage on this side, right? So there's less there's less charge, so the charge goes down. Questions on that?
So the charge goes down?
Why does the charge go down?
No, it does go down.
Why does it go down?
Because there's a higher charge on the other side.
Right.
Okay.
Yeah, we're forcing more charges to the other side. That field, the voltage goes down. And because we're increasing the voltage is more charge there. Because I don't change the capacitance. This equivalent capacitance here does not change, right? We're not changing anything about the fundamentals here. So, and it's interesting when I asked, I said, well then what happens, okay, what happens then to C1? You know how many, happens to C1, how many of you said the capacitance goes up or the capacitance goes down? Well, you're not doing anything to see what? We're not inserting a dielectric in there, we're not changing the properties of C1, so why would the capacitance go down? Capacitance is a fundamental principle of the capacitor. If I'm not changing anything about the capacitor, then the capacitance stays the same. Yes?
For the previous question, I thought that when the battery is connected, then the voltage would stay the same.
It stays the same across this branch.
The voltage stays the same.
This voltage stays the same. This is why your, I don't want to say ignorance, but your lack of understanding of circuits comes into play. We're not changing this voltage. This is okay, so there's 24 volts across this branch. From A to B, there's 24 volts. It can be shared amongst these branches differently, and that's what's happening. I'm forcing, when we were in our discussion, we had one voltage and one capacitor, and I said, when we hold this 12 volts here, the voltage stays the same. But then you think, oh, he said the voltage stays the same. It's a loaded gun. You don't know how to use it. It stays the same across these principles, but it doesn't stay the same across these branches. Because we are putting a dielectric here, we're forcing the voltage to be higher here because we're decreasing the voltage here. Does it make sense? Yes.
So just for the sake of like crystal clear understanding, so when you enter the dielectric,
Okay.
capacitance increases.
Yep.
Okay. Voltage decreases for C3.
For this, and yes,
And then that means that the energy also decreases.
yes.
And then charge remains constant or also
No.
decreases?
The charge in this situation decreases because the voltage, watch, we have to reason this out, right? So the voltage goes down. Are you okay with that?
Yeah.
And we said that the voltage across A and B stays the same. So if the voltage goes down here, what has to happen across this branch? The voltage has to go up.
Right.
If the voltage goes up and the capacitance stays the same, what happens to the charge?
It decreases. Or sorry, increases.
It goes up. And we don't have conservation of charge is a fundamental principle rule. That means if charge goes up here, it has to get charged from someplace.
Right.
And where's that charge coming from?
C3. So capacitance is the only thing that increases in C3.
Correct.
Okay. And then for C1, is it the opposite?
So in this case, we know capacitance does what?
Stays the same.
Stays the same. Charge goes up, voltage goes up, energy goes up. Because QV goes up. And energy is 1/2 QV. Questions? Does that help? These are not easy. These are really challenging questions you really have to fight with and think about. AI can't help you. I mean, I can give you answers, but I can't make you think. All right, I wish it could. Okay. Now, we're removing the battery. And then we put the dielectric in. So when we do that, we do know that there is no place for the charge to move. The charge is not gonna flow, it's gonna stay the same. So that's the one caveat, charge stays the same. Why? Because it has nowhere to move, it's gonna stay the same. So in this case, what changes take place between C3? We remove the charge. Well, we know that the charge stays the same. We do know that.
I'm wrong though, just don't look at it.
We also know that C3 goes up. Why does it go up? It goes up because K goes up. K goes up. So see, and so voltage then goes down.
I'm a genius.
So we've got capacitor goes up, capacitance goes up, voltage goes down, Q stays the same. So then what happens to the energy?
I think I got all of them.
It goes down. That's QV, 1/2 QV. Q stays the same, voltage goes down, goes down.
I said voltage energy will decrease. Then I said charge.
Questions?
I said capacitance
7
will
was hard,
decrease.
this one is pretty rational, yes.
Charge increase,
So,
I switched them.
Isn't just a general rule in this kind of circuit that energy and voltage vary together?
Yes, because voltage, the reason voltage goes down is because the field goes down.
Right. So they will always act together. So either they both increase or both decrease or both stay constant.
Yes.
Okay.
Questions? Yes.
Why does the charge stay the same here, but it goes down in the other one?
Because in this one, the voltage is, and once again, you're not having circuits, we don't really understand that, right? But what does voltage do? The voltage supplies the charge. Okay, so if the voltage source is here, it can supply and take away charge, okay? But if we take away that, if we disconnect it and have an open circuit, then the charge is gonna stay where it is, it's not gonna flow. Does that make sense?
Yeah.
And we're gonna actually start to experience it in about 10 minutes. All right, anybody else have questions? Okay, so that, getting over those is challenging, all right? This is the, okay, so 10, describe what changes take place in C1. Well, nothing changed. C1 and C2 stay the same, charge stays the same, voltage stays the same, energy stays the same. Question? All right, this actually is an AP question, just taken right from that. That's an AP right out of the equation sheet. So this is an equation sheet one. We're trying to work.
Which one?
Okay.
Which one is it?
This right out. This is right out of your equation sheet. And this is the definition of work. Okay. And work is the electric field per charge. Okay. So work done on a test charge.
Okay, so it's KQ squared over R.
Yeah.
What's the reason?
I'm doing my video in segments, so if I screw up one, the rest is fine. I'm like a vlogger.
You know what? It might be R squared.
I thought it was R squared.
Yeah, actually, it is R squared. Yeah, because that's the work is the.
But isn't it from the other charge, so it's the third one? Like, third answer, not the fifth.
You mean this one?
No, scroll up a little bit, isn't it the one above, because you're going from 0 to Q, should be from. Oh, no. Isn't it K over?
Well, it's because work is the derivative of potential energy.
Wait, no, it's not. It
Charlie
is.
Smoker.
No, it is this one.
Oh.
It's this one. I'll go over it. It's, hey, work is the integral of E dot ds, right?
We're going this side.
And what is, and so dq
Oh my god.
is
All the
equal
PLA is
to,
gonna
this
hear
is a
Yeah.
line integral. Potential is a conducting
Yeah.
sphere. Alright, the voltage equation.
From left.
She was showing me like their language, you know, like
Equation to a
I
drive
the
of the sphere.
one that went
Okay, and then we know that E, V is equal to E dot ds, right? So and that's the work on that, so E is equal to so that's gonna be, that's the gradient, so what we're gonna do then is we are gonna look at the voltage. So we plug that into that. We get work. The voltage, which is KQ over R. And then the S's cancel, and then you get Q, and this is from 0 to
Yes,
Please.
It is, we were right, yeah. Okay. I was right originally, and then I'm getting confused.
It's just KQ over R.
Yeah. Yeah, because we're replacing E with voltage over ds. So we're getting rid of ds, and we're replacing it with respect to Q.
So is it KQ squared or just KQ? Because oh,
It's just,
okay. So the third option?
yeah, I'm sorry, KQ. Yeah, the one that I originally
I
had.
got that right, dude.
I'm messing up.
I got it.
So
I have
is
both of our tests.
work defined as the integral
Yeah.
of
And we can compare
It's
what we
this
did
one.
on Ash.
Yes. Yes, it is.
I've gotta be a genius. I've gotta be a genius.
Well, that's called the gradient. So it's
Me
the
too.
partial derivative with respect to, it's the negative gradient. Yeah.
Wait, so the official formula for work in this context is is negative the integral of dV.
Work, work is the work done is F is the force times the distance, right?
Right.
Yeah, and force is E over Q. Right?
Right.
So so work is just the integral of F ds. But then we start plugging in, well, what's F? What's electric force? The electric force is EQ. And so then now we're starting to get it, to get it in terms of voltage. What is voltage? Voltage is V over Q, is which is the integral of E dot ds. Right? Okay, so that's one of those equation ones that we went through. But that's just right off of AP, it's a right off of an AP test. All right, so then here, we're just moving two plates across, and then we need to know that if the field increases, the magnitude of the electric field decreases by 2. 13, this is one that we need to talk about. If the electric field is 0 everywhere inside the region of space, Gauss's law tells us something. John, what does the Gauss's law tell us?
The charge could be equal. Hand in hand, we will.
What is Gauss's law? Can you tell me what Gauss's law says?
Yeah.
The flux through a surface is proportional to what inside it?
The charge inside.
Charge inside. So if the flux is 0, then what is the charge inside? 0. And so the electric flux is
That's so
0 and the charge
obvious.
is
Am I
in 0. But
stupid?
those are the first two choices, and yet how many people chose them? This is just Gauss's law.
Why is?
Now, what about potential? Potential, I drew these two graphs, okay, earlier in your notes. So if we are going outside a conductor, the inside a conductor we know is 0. Because why? Because there is no charge enclosed and, right, there is no flux because there's no field. So we have 0 down here. But potential, yes, there is potential inside a conductor. There is potential inside that area. It's constant, it's not changing, but there is potential, and then it decreases with 1/r. Yes.
Isn't D also true, like, even though there's no change in potential, there's no difference between the area?
I literally wrote them in my notes and I still got the question with them wrong.
Voltage and electrical potential potential.
Voltage is a number, electric potential can be different, right?
Yeah.
So D is also correct, right?
Yeah. Yeah.
Wait, oh,
Yeah,
these
that's
also
true. But I
count?
didn't take points off of that, but I did take points off if you didn't have these two.
Julie, he said he's
And
also
if you
correct.
did, I gave you 1 point no matter what, so.
Wait, so D is also true?
I can't really see it.
Right now I'm getting confused, but yes, I think, I know voltage is constant inside. And I'm pretty sure electric potential difference is the same as voltage.
So it's only A and B.
I think it's A and B is the correct answer, but let me go check. I do believe it's A and B.
Can we go back to number
Voltage and electric potential difference, I think, are the same. But okay, so when we say electric potential, there is no meaning to that. That's just, that's at a, if we do a reference, we give it a reference at infinity, then we can measure it, we can talk about it.
It's like, voltage is like the unit, but electric potential difference is the change in voltage. So
It's a change in voltage, but when we take it from infinity,
Yeah.
okay, then we can look
You're
at
going
that,
out?
and just as we can say,
Usually when we're referring to voltage, we're referring
that's
to.
why it's a trick question, when we say, yes, correct. Okay, 14. This one, these are all clicker questions. This clicker question was, the answer was negative, and it's still
Yes.
negative. Doesn't change, but how many people got wrong? Lots. Clicker question, this is not a clicker question. The field, though, is parallel. Why is it parallel? What does it tell us? It tells us that the field is even, it's the same. Okay? The field lines are determined by the spaces between the field lines. So the field lines are the same, they're parallels, it's gonna be the same. The field's gonna be the same throughout. The potential is not the same. Potential is the field is going from negative to positive. I'm sorry, from positive to negative. So A and B are closer to the positive. That means that they have higher potential. C is closer to the negative, so it has lower potential. If it's closer to the negative, it's lower. Closer to the positive, it's positive. So A and B are more positive than C. So that's not correct. They're not all the same potential.
So it's A and B.
Alright, and then an electron moving from A to C does positive work against the field? No, because the field, the force is one way and the field is the other. So if the force and the field are in opposite directions, the negative work is being done. A positive test charge loses electric potential? Yes, because it's gaining kinetic energy. If it's gaining kinetic energy, it loses its potential. So it's A and B. Okay? Yeah, maybe? Alright.
Yeah.
16, and we're learning something? Alright. Which of the following quantities do not have to be 0 inside a conductor? Well, just look at the graph. Look at the graph. Alright,
I memorized them
17.
backwards.
Suppose you have 2-point charges of opposite sign. You move them further and further apart. The potential energy of the system relative to infinity increases. This is a clicker question. Questions? Okay. Alright, so you will have I'll have a retake, I'll open it up, you can do it over
Wait,
the weekend.
Mr. Farrell, I think there's one more question.
I don't think so. Oh,
18?
yeah. What is the direction of the electric potential gradient? This is a clicker question. The answer was opposite, because the negative sign, E is equal to the negative of the partial. Yes.
Can we go back to 16? That's electric potential, right?
Yeah.
Potential. Different 'cause it's the gradient.
Okay. Now, on to better things.